picture, all of you. So we have a very nice logic, restriction fragments. ध्यान से सुनना, very crucial topic. A restriction fragment is a DNA fragment resulting from the cutting of DNA strand by a restriction enzyme, restriction endonucleases, a process called as restriction. Do we remember last lecture we had said restriction endonucleases cut the DNA into small fragments. They are called molecular scissors or genetic scalpels, and after restriction endonuclease cuts the DNA, the fragments which are formed by cutting with restriction endonuclease, those fragments are called as restriction fragments. सबसे पहले Lin and Arbour isolated two enzymes in 1963 which restrict the growth of bacteriophage in bacterium E. coli. So sir, why is a restriction enzyme found inside a bacteria? Who attacks the bacteria? Bacteriophage. And bacteriophage puts its own DNA inside and tries to complete the lytic cycle, as we just said. Who protects the bacteria from attack by bacteriophage is restriction enzyme. So restriction enzyme will cut away bacteriophage DNA and prevent the bacteria from getting lysed by the bacteriophage. So restriction enzymes are the immunity of a bacteria. They protect the bacteria from attack by a bacteriophage. And सबसे पहले all restriction enzymes belong to larger class of enzymes called as nucleases. So restriction enzymes का larger class of enzymes are called nucleases, और nucleases दो टाइप के होते हैं, exonuclease and endonuclease. Exonucleases remove the nucleotides from the ends of the DNA. तो ये है DNA और इसके दोनों ends से cutting is done by what enzyme? Cutting is done by enzymes which are called as exonucleases. But endonucleases cut the DNA at specific position within the DNA. And they cut the DNA within the DNA, so endonucleases cut it within the DNA. So where do exonucleases cut from? The ends. And by the way, which bonds will they break? They will break hydrogen bonds. They will break which bonds? Hydrogen bonds. Where does restriction endonuclease or endonuclease break? Within the DNA. So which bonds will they break? Phosphodiester bonds. Phosphodiester bonds are broken by endonucleases. Exonucleases cut from the ends of the DNA. Endonucleases cut within the DNA and form fragments called restriction fragments. Restriction endonucleases serve as tools for cutting DNA molecules at predetermined site, which is the basic requirement for gene cloning or DNA recombinant technology. Restriction endonucleases तीन टाइप्स के होते हैं, namely type 1, type 2 and type 3, and they all have slightly different modes of action. Type 2 restriction enzymes are used in recombinant DNA technology. So we have type 1, type 2, type 3. Type 2 is the restriction endonuclease which is used for cutting in the DNA recombinant technology. And third, there are more than 350 different types of endonucleases with 100 different recognition sequences. How many restriction enzymes are known by scientists? 350 restriction enzymes. And how many sequences are found in the DNA to cut it, sir? More than 100 different sequences are known. So you know 100 different sequences for cutting, and sir, 350 different types of restriction endonuclease enzymes are used for that. And sir, how is the nomenclature or naming done? Restriction endonucleases are named by a standard procedure. The first letter in italics indicates the genus name. The first letter is name of genus in italics. The first two letters next are the name of the species. Then comes the strain of the organism, and finally a Roman number indicating the order of discovery. तो सबसे पहला वर्ड restriction endonuclease का कौन है? Name of genus. Next two letters कौन है? Name of species. Then third is strain of organism, and then a Roman number indicating order of discovery. For example, EcoR1, the most commonly used restriction endonuclease enzyme is EcoR1. Neat point of view, ये याद रखना, most commonly used plasmid is PBr322, and the most commonly used restriction endonuclease enzyme is EcoR1. So what does EcoR1 stand for? E stands for Escherichia, name of the genus. CO stands for coli, name of the species. R stands for strain, RY30. That is the name of the strain, and it is the first endonuclease to be discovered from E. coli. So it is called Escherichia coli R1. EcoR1, E for Escherichia, CO for coli, R for the strain RY30, and it is the first endonuclease discovered. So it is called EcoR1. Similarly, Hind-Cree, H stands for Haemophilus, IN stands for influenza, D stands for the strain RD, and it is the third endonuclease to have been discovered, so it is called Hind-Cree. EcoR1, Hind-Cree are two very commonly used restriction endonuclease enzymes. अभी restriction sequences कौन से होते हैं? A recognition sequence or a restriction site is the site where DNA is cut by restriction endonuclease enzyme, which is a particular sequence of 4 to 8 nucleotides, and the DNA restriction enzyme cuts the DNA. So restriction endonuclease enzyme cuts the DNA in a specific site, and that site is called as recognition sequence. That site is 4 to 8 nucleotides. 4 to 8 nucleotides का specific site. Most restriction sequences are palindromes. Most restriction sequences are palindromes. In English, we have heard the word. What is a palindrome? They are groups of letters that form the same word when read both forward and backward. So groups of letters which are form the same word when read both forward and backward. For example, Malayalam. So sir, MALAYALAM, अगर हम उसको उल्टा पढ़े MALAYALAM, तो Malayalam is spelled forward and backward the same. It is called as a palindrome. Similarly, madam, 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 madam. So madam is forward and backward read the same. What is that known as a palindrome? And restriction enzyme cut recognition sites which are palindromes. So sir, in the DNA from 5' to 3' EcoR1 cuts a specific site GAATTC. Sir, 5' to 3' what is this sequence? GAATTC. So 3' to 5' what is the sequence? G pairs with C, A pairs with T, A pairs with T, T pairs with A, T pairs with A, C pairs with G. But if you read 5' to 3' it is GAATTC. If it is read in the other strand from 5' to 3' what is the sequence? GAATTC. C. Hey, this is GAATTC. This is GAATTC. So read forward and backward, it is the same sequence. What is such a sequence called as a palindrome? And where does EcoR1 cut? It cuts the phosphodiester bond between G and A. G and A के बीच में phosphodiester bond टूटता है. And once G और A के बीच में phosphodiester bonds are cut, then it will cut the hydrogen bond between AT, AT, TA, TA. AT, AT, TA, TA के बीच में hydrogen bonds are cut. And that means this will become one segment and this will become another segment. तो ये DNA का एक सेगमेंट बन जाएगा और ये DNA का दूसरा सेगमेंट बन जाएगा. So we have now cut here and we have cut here, and these are ends which are called as sticky ends. What are these ends called as? Sticky ends. And sticky ends are produced with the help of EcoR1, which has cut the palindrome GAATTC, GAATTC, and we have got ends which are called as sticky ends. तो इस तरह से sticky ends बनते हैं. And then sir, याद रखना ये you require magnesium ions for this cleavage. तो इस cleavage के लिए कौन से इलेक्ट्रोलाइट्स की जरूरत पड़ती है? मैग्नीशियम. And sir, how is sticking done? How is sticking done? Sir, you have the insertion done this way, sir. Insertion कैसे किया जाता है? Sir, we cut GAATTC in a plasmid. तो प्लाज्मिड में G और A के बीच में कौन सा बॉन्ड टूटेगा? फॉस्फोडाइस्टर. G और A के बीच में फॉस्फोडाइस्टर. Between AATT and TTAA, which bonds are cut? Hydrogen bonds. तो ये कौन सा बॉन्ड तोड़ा हमने? फॉस्फोडाइस्टर. ये कौन सा बॉन्ड तोड़ा हमने? फॉस्फोडाइस्टर. और ये कौन से बॉन्ड्स तोड़े हमने? हाइड्रोजन बॉन्ड्स. एंड वी गॉट एंड्स व्हिच आर कॉल्ड एज स्टिकी एंड्स. तो ये कौन से एंड्स बने आपके? स्टिकी एंड्स. दिस इज अ स्टिकी एंड एंड दिस इज अ स्टिकी एंड. तो ये स्टिकी एंड है, ये स्टिकी एंड है. वी गॉट स्टिकी एंड एंड वी गॉट स्टिकी एंड. एंड वी यूज द सेम रेस्ट्रिक्शन एंजाइम फॉर कटिंग द ह्यूमन डीएनए. तो ये प्लाज्मिड डीएनए सेम एंजाइम से ह्यूमन डीएनए कट किया जाता है. से दिस इज द जीन फॉर इंसुलिन. जीन फॉर इंसुलिन. एंड विच रेस्ट्रिक्शन एंजाइम वी यूज? EcoR1. एंड EcoR1 will cut the same sequence. G और A के बीच में कौन सा बॉन्ड? फॉस्फोडाइस्टर बॉन्ड. G और A के बीच में कौन सा बॉन्ड? फॉस्फोडाइस्टर बॉन्ड. और AATT TTA के बीच में कौन से बॉन्ड्स टूटेंगे? हाइड्रोजन बॉन्ड्स. एंड हियर आल्सो G and A के बीच में फॉस्फोडाइस्टर, G और A के बीच में फॉस्फोडाइस्टर, AATT TTAA के बीच में हाइड्रोजन बॉन्ड रखा. And once this cutting is done, what is the sequence we got? We got gene for insulin, we have G here, and we have CTTAA here. And other strand, we have AATTC here, and we have G here. And this gene is the gene for insulin, and this gene is now inserted into the plasmid. And plasmid के अंदर ये डाल दिया. Sir, what will the G pair with? G will pair with C. A G will pair with C, and that is there. G and C. G pairs with C. G G and A के बीच में we will create a phosphodiester bond. G और A के बीच में phosphodiester bond. G और A के बीच में phosphodiester bond. G और A के बीच में phosphodiester bond. And phosphodiester bond is made with the help of ligase enzyme. So which enzyme is used for cutting, restriction, endonuclease, and which enzyme for sticking? Ligase. तो G और A के बीच में ये phosphodiester bond किससे बनाया? Ligase. ये G और A के बीच में phosphodiester bond किससे बनाया? Ligase. G और A के बीच में phosphodiester bond ligase. G और A के बीच में phosphodiester bond ligase, and ligase will stick it, and automatically, because these were palindrome, what is the sequence here now? AA, TT, and what is the sequence here now? TT, AA, or AATT. और A और T के बीच में क्या बनेगा? हाइड्रोजन बॉन्ड. A और T के बीच में क्या बनेगा? हाइड्रोजन बॉन्ड. A और T के बीच में क्या बनेगा? हाइड्रोजन बॉन्ड. A और T के बीच में क्या बनेगा? हाइड्रोजन बॉन्ड. Similarly, here also AT hydrogen bond, AT hydrogen bond, TA hydrogen bond, TA hydrogen bond, and we have got excellent phosphodiester bonds created by ligase, and hydrogen bonds are beautifully created because of complementary base pairing, and this is now plasmid DNA, this is the foreign DNA, this is the gene for insulin, and this plasmid plus gene for insulin is now called as a recombinant DNA, also called as a chimeric DNA. And this recombinant DNA or chimeric DNA is now put inside a bacteria, and along with the plasmid multiplying, the gene for insulin will also multiply, and the gene for insulin will undergo transcription translation to produce a lot of protein called as insulin. So beautiful concept. So what are these forward and backward repeating sequences called as? Palindromes. What do restriction enzymes cut? Palindromes. So I hope you all have understood this thoroughly well. Please read up this part well. Next session we go in the details of biotechnology. We understand how is DNA recombinant technology carried out. Okay, please study this part well. Take care. God bless.